Hello everyone. Have you ever wondered how to quickly expand expressions like a plus b whole to the power n without using long multiplications? There comes the binomial theorem. So this gives us a simple formula using special numbers which are called as binomial coefficients. So this trick saves us time and it is super useful in mathematics and probability and even in our real life. And the best part of this video is we are going to prove how this binomial theorem works, and also we'll understand step by step how it really works. So stay tuned and grab your notebook. We will understand each and every step of this proof, which will be very most important in your examination. So let's get ahead to the theorem. So in exams, first and foremost, they'll ask the question like state and prove the binomial theorem. So in order to write the statement and the proof, first you should know what is the statement of the binomial theorem. So let's understand the statement of the binomial theorem. So it states that for any positive integer n, so any positive integer n is nothing but n should always be greater than 0, means it should be a positive number. So the expression is a plus b whole power n can be written as nc0 a power n plus nc1 a power n minus 1 into b plus nc2 a power n minus 2 into b square plus etc. You will get ncn b power n. You know that where nc0, nc1, nc2, all these are binomial coefficients. You people are well known with these binomial coefficients which you have encountered in your permutations and combination chapter. So you people are well known what this nc0, nc1, nc2, etc. in this statement. So let's prove the binomial theorem by the use of the method of mathematical induction. So first and foremost, we have to prove that the given statement is true for the value n equal to 1. So wherever n is there, substitute it as 1. So this will become a plus b whole power 1, which is equal to 1c0 a power 1 plus 1c1 a power 1 minus 1 into b. Since it is ncn, we have to stop it here only. You people are well known a plus b whole power 1 is nothing but a plus b, which is equal to nc0, which is equal to ncn, which is equal to 1. So nc0 value, 1c0 value is 1 into a power 1 is a plus ncn, which is 1c1 value is 1, and a power 0 is nothing but this is also 1 into b. So this will become a plus b, which is equal to a plus b. So this satisfies LHS equal to RHS, the given statement. So therefore the result is true for n equal to 1. So since it is true for n equal to 1, if you want, you can even check n is equal to 2. The result will become true for n equal to 2 also. So the result will become a plus b whole square, which is equal to a square plus 2ab plus b square as a answer. So the result is also true for n equal to 2. So it is enough if you do for n equal to 1. n equal to 2, if you want, you can substitute and you can write. Since the result is true for n equal to 1, and also if it is true for n equal to 2, we can assume that the result is true for n equal to some k value. So n equal to k. So what the statement will become? This will become a plus b whole to the power k. Means wherever n is there, you just substitute k, which is equal to kc0 a to the power k plus kc1 a to the power k minus 1 into b plus etc. plus kck a to the power 0 b to the power k. Assuming that the result is true for n equal to k, if it is true for n equal to 1 and also n equal to 2. Consider if the result is true for n equal to k value, it should be true for the next value also. So since it is true for n equal to k, we have to prove that it is true for n equal to k plus 1 also. So what we have to prove here is, we have to prove the result is true for n equal to k plus 1. So what it will become? A plus b whole power k plus 1, which is equal to k plus 1 c0 a power k plus 1 plus k plus 1 c1 a power k b plus k plus 1 c2 a power k minus 1 b square plus etc. plus k plus 1 c k plus 1 b to the power k plus 1. So this is what we have to prove. So in order to prove that the result is true for n equal to k plus 1, we will take the LHS and also we will prove that it is equal to the RHS. So whatever the LHS is there, you write it as it is, a plus b whole power k plus 1. So this can be written as a plus b to the power k into a plus b by the use of law of indices. So since we know that a plus b whole power k value. So what is a plus b whole power k value? So this is what they have given. So this can be written as, this a plus b you write it as it is, which is equal to a plus b I am writing as it is. This a plus b whole power k can be written as, this you copy from the a plus b whole power k. This will become kc0 a power k plus kc1 a power k minus 1 into b plus kc2 a power k minus 2 into b square plus etc. kck b power k. Now you have to multiply a plus b to the each term here. So first I will multiply this a with the each term, then I will multiply b with the each term. So let's multiply. If I am multiplying a to the each element, this will become kc0 a power k is already there. If I am multiplying a power 1, so it will become k plus 1 plus kc1 a power k minus 1 plus 1. So it will be k b plus kc2 a power k minus 1 b square plus etc. plus kck a b power k. Since I have multiplied a to each element, now it is the term of b which we have to multiply to the each element. So this will become plus, now multiply b to each element. You will get kc0 a power k into b plus kc1 a power k minus 1 into b square plus kc2 a power k minus 2 into b cube plus etc. plus the last one is kck b power k plus 1. So here I have multiplied a to each element and also b to the each element. You people can observe that this kc0 a power k plus 1 is a single element and kck b power k plus 1 is also a single element. Apart from that, you can observe these terms. See here, in these two terms you can get a power k and b as a common, and in these two elements you can get a power k minus 1 b square as common. In a similar manner, you will get common in each and every element except these two, which is at the first and at the last. So write whatever is there as it is. Now kc0 a power k plus 1 will remain as it is, plus now you can observe that from these two you can take common as a power k and b. So what's remaining? kc1 plus kc0 plus again from these two you can take common as a power k minus 1 into b square. So what's remaining? It is kc2 plus kc1 plus etc. If you are taking these elements, you will get common for this element as the element here, and the last one, this will also get some common here. In a similar manner, you will get common for each and every element except the first and the last term. So the last term is k ck b power k plus 1 will remain as it is. Since we know that the formula of the combination, that is, so these are the two formulas which from the combination. So these are the two formulas from the combination which we are using in order to prove the binomial theorem. So first one is NCR plus NCR minus 1 is equal to n plus 1 CR. So you can observe that this is of the form KCR plus KCR minus 1 means 1 minus 1 which is 0. So KC1 plus KC0 can be written as K plus 1 which is n plus 1 CR. R is nothing but 1 here. So this term can be represented as K plus 1 C1, and this one can be written as KC2 plus KC1 means 2 minus 1 is 1 which is equal to K plus 1 C2. Now substitute it and we will get the answer of the binomial theorem. And KC0 can be written as K plus 1 C0. We know that KC0 is equal to 1. In simple terms, we can also write that K plus 1 C0 is also equal to 1. Since also KCK is equal to 1, we can also write K plus 1 CK plus 1 is also equal to 1. So substitute all these values, you will get this is equal to KC0 can be written as K plus 1 C0 a to the power K plus 1 plus this thing will be as it is. Now this can be written as K plus 1 C1 a to the power K B plus this one can be written as K plus 1 C2 a to the power K minus 1 B square plus etc. Plus the last term is KCK can be written as K plus 1 C K plus 1 B to the power K plus 1. Now you can observe that you have taken the LHS which is A plus B whole to the power K plus 1, and you have proved the RHS which is given in the to prove. So RHS is as it is. Therefore you can write that LHS is equal to RHS. Hence the proof of the binomial theorem. So if you are having any doubts, please let me know in the comment box so that I can clear all your doubts. If you like the video, please do like, share and subscribe to my channel, and don't forget to press the bell icon so that you'll get all the updates in a timely manner. Thank you for watching.